Hi all, welcome to Learn Code Repeat. So today we'll be looking at day 4 of the October LeetCode challenge. The name of the problem is remove covered intervals. Let's look into the problem. So the problem says given a list of intervals, remove all intervals that are covered by another interval in the list. Interval a comma b is covered by interval c comma d if and only if c is less than or equal to a and b is less than or equal to d. After doing so, return the number of remaining intervals. So basically the question asks is if there is an overlapping interval, then all the sub intervals inside that needs to be not considered, and only the main overlapping, that is the superset interval, needs to be considered, and give the count of that. So let's look into the first example. Here we have 1 4 3 6 and 2 8. So let's plot this example. So 1 4 will be like this. This is the interval. 3 6 is from here to here, and 2 8 is from here till here, right? Now if you see what the condition it says is the interval that is covered by a super interval, right? So this is a super interval which covers this particular interval, right? So this should not be considered, and then return the count of whatever intervals are not covered, right? So this will be 1, this will be 2, so the output is expected to be 2, right? Now if you see this, once you plot it, it looks like very simple to identify the intervals that are not covered, right? The condition here was a comma b, c comma d, and a is less than or equal to c and b is less than or equal to d, right? So if it is a comma b and c comma d, then c should be less than or equal to a, and b should be less than or equal to d. What this means is, this is my a and this is my b, right? And this is my c and this is my d. So here c, if you see, c is 2 and a is 3, so c should be less than or equal to a, that is what is given here. D is greater than or equal to b, or in other words b is less than or equal to d, right? That is what is given here. So if this is the condition, that means this CD is overlapping AB, right? In that case we should not consider AB. Okay. So the reason once you plot it you are able to identify is because you see this, you visualize this as a sorted interval, right? So that is what we can do here. We can directly sort this array because this is an unordered array. We can sort this interval array, and once you sort this, you can see that based on this condition you can identify if the interval is overlapping. That means if this condition is satisfied, that means the interval is overlapping. So when I sort this, right, this superset will come first and then this will be coming, right, in this case, at least in this case, right. So if this is my current I position, right, or let us say this is my previous interval which is I position, and this is my current interval which is j position, right. So I just need to check whether interval of my previous position, which was I of 0, is less than or equal to, I am using the same condition a is my current intervals position, right, j comma 0. Okay. If this is the condition, and here it will be b, right, b is this is j, so that is my current 0 is less than or equal to interval of, sorry, here it will be 1, current 1 is less than or equal to interval of I1, right. So in that case, if this is less than this, if that condition is satisfied, then my current interval needs to be removed from the total length, right. So let us say if I am having a count variable which is 0, right, I can simply increment that count, right. But if that is not the case, right, then my overlapping, right, should be considered as my current. So my previous, right, previous j, or rather previous I should be equal to j. I is my previous index, right. So I should point to j, and that we can do it in the for loop once we have the sorted array. So this is a very simple algorithm that we can use. However, there is a catch here. The way we sort it is important, because we not only need to sort it by the starting index, but we also need to consider the ending index. Let us take another example. So here I have plotted the graph. I'll come to this part later on. So here I have plotted the graph, and if I see this particular interval is overlapping this, so I have crossed out this. Similarly, this interval is overlapping this one, I have crossed out this, and this interval is also overlapping this, so I have crossed out this one as well. So at the end we have only two largest intervals, so that is why the output is 2. So here if I only sort by the starting index, right, so if you see this can come first or this can also come first in the array, right, if I sort the array only by start index. And if that is the case, then our condition of C is less than or equal to A and B is less than or equal to D, right. To satisfy this condition, we have to identify which of the interval is C, right, which is AB and which is CD. It can be that this is AB and this is CD, or it can be the other way as well, right. So to check that, we have to also check which one is having the largest n index, right, which is the maximum n index in that case, and we have to take that as the CD. Okay. So to keep a track of that, right, we have to create one more variable to keep a track of which one is the largest index, and so point that variable to that particular largest index. So to remove all this complexity while sorting, we can very well sort by start index and end index, right. So what will happen in that case, right? So when I sort with start index and end index, I will sort by start index in ascending order and by end index in descending order. So my output will be something like this, right. So 1 7 will be first because 1 and 1 is same, but 7 is greater than 4. Because we are sorting the n index in descending order, this will come first, right. So let me write down the index value here. So this will be 0, this will be 1, this will be 2, this will be 3, and this will be 4, right. So here I am making sure that the largest overlapping interval will come first before its sub intervals, which the largest may be overlapping with that, right. So once I have that order in place, right, I can very well say that my current interval, if it is largest, that is the C and D value, right. So I can start with saying that I equal to 0, I is my largest overlapping interval and J is my current counter, which is the next interval, right. And I can have this J in a for loop, J equal to 1 till J is less than my length of the interval and J plus plus. Okay. Now I can, in my for loop, I can just do this check, right, that they have provided. So I is my largest interval, right. So I of 0 is less than or equal to J of 0. Okay. So I am checking first this particular condition, and now B is my J value, J of first index is less than or equal to interval of I of first index. Okay. If this condition is satisfied, right, that means my I index interval is overlapping my J index interval, right. So I am incrementing the counter. Okay. However, if this condition is not satisfied, right, so that means my current J interval is not getting overlapped by the I interval, right. So when I go to the next counter, my J interval may be overlapping the J plus 1 interval, that may be the case, right. So in that case I need to assign I as the J value. So basically I is keeping the track of which interval may be overlapping the next interval. So this is the simple logic here. Now let us code this algorithm. So first I will get the length of the array. Now if my interval is 0 length, or even if it is of size 1, right, I can directly return the output as the length value, right. So I will add that check here. So I am assigning my I index as 0 and my J will start with 1. I will also assign a variable counter to count the total number of intervals that are getting overlapped. So initially it will be 0. Now the if condition will be there. If this is the case, then I need to increment my counter, else my I will be equal to my J. Okay, this will be my condition inside my for loop, and before this I need to also sort my array. So here I will do a arrays dot sort intervals, and the comparator will be if my 0th index is not equal to my other 0th index in that case. So if my a of 0 is not equal to b of 0, that means my start index are not equal, then I can directly do a ascending order for my start index, else I need to do descending order for my end index if my start index are same, right. So this is my comparator for the sorting order, and once I have the counter incremented, that means I am counting all the intervals that are getting overlapped by some other interval, right. So once I know that, right, I can very well return my length minus the count. So this is the remaining value, right. So let's submit the code and see whether it works fine, and the code is accepted. So the complexity of this algorithm will be O of n log n. The reason why it's O of n log n is because we are doing a sort here. So sorting takes O of n log n, and after that we are going through the intervals again, which will be O of n. So it will be O of n log n plus n, which is same as O of n log n. So the time complexity is O of n log n, and since we are not using any additional space, so the space complexity is O of 1. Hope you like this video. If you have any question, please do write into the comment section, and if you haven't subscribed to the channel, please do subscribe to the channel. Thank you.